Right guys, welcome back to another video. So today we're going to be doing one question for every single grade of GCSE Further Maths. Firstly, we're just going to start with some notes. These questions, apart from one of them, were all taken from past papers. Just to note that the grade level of the question, you should be able, if you are that grade, you should be able to do the question, and then you might struggle with the next one. Also keep in mind that this difficulty is subjective, so you might be stronger on certain topics than you are on other topics. And we're going to get started. So we're going to get started with our grade 4 question. We're not going to do a grade U question because you might as well just not be in the exam. And so we're going to start with this question. So this is just like a normal GCSE style proof question. That if you can pass Further Maths, then you can do this question. So we're going to start by expanding the numerator, but remember to keep them in brackets just because of the negative that's there. And then we're going to distribute the negative, and you can think about it with the right bracket, you're kind of expanding the bracket with -1 as your coefficient of the bracket, just if that makes it easier. Then we're going to collect all the like terms. We're going to get 2n, and we're going to write our statement like we should do in every proof question. Right, next question, we're going to be going on to grade 5, and we're just going to be doing some simple differentiation, like this. So you can pause the video, try and do the question. Right, we're going to do this one term at a time. So the first term, we're just going to be doing simple power rule, getting 18x squared. Next term, we're going to be getting rid of the x because it's to the power of 1, so we're just going to get 40. And then the next term, we multiply it by -2 to get +6, and then lower the power by 1 to get 6x to the -3. And then the 40 becomes nothing because of constant rule. Right, next question, we're getting on to the grade 6 question. We're going to be doing some matrices. So if you can understand how to multiply the matrices, then you should be able to do this question quite well. We're just going to put them into one big matrix like this, and then that is the difficult part kind of done, and we're just going to be able to compute all of this. So firstly, we're going to multiply everything that's in the brackets, and then we are going to get rid of the zeros. Then we are going to get rid of this 8 minus 2, and then we're going to distribute the scalar into the matrix. Alright, so next we're going to go to the grade 7 question. So this definitely could come up in a normal GCSE. There's no further maths topic that's affiliated with this question, but I do feel like a lower grade student will kind of just look at this and go, oh, no thanks, because this is just doesn't look very nice. It's on the last bit of the paper, but actually it only requires a few steps. So we're going to go through it slowly. So firstly, we're just going to rewrite the right fraction as to the power of a half, and we're going to multiply the algebraic fraction so they have the same denominator. Next, we're going to flip the fraction and turn it into a multiply. Then we're going to combine the algebraic fractions, and we're going to square root both sides of the fraction, which is what you do when you square root. And now we're just going to do normal fraction multiplication to get 22x over 10x cubed, and then we're just going to simplify this. Right, next we are going to go to grade 8. So this question is classic. This comes up almost every year, where it gives you a curve, tells you to find the stationary points in the nature. If you just practice this question at a lower grade, it's extremely easy, but most people don't because they don't care about further maths as much, so they just kind of don't practice like the questions that always come up. So we're going to firstly differentiate, as we always should. We're going to get 4x cubed minus 36x. You should know how to differentiate at this point. We've moved on from grade 5. Next, we are going to set it equal to 0, and we're going to factorize x out to get x equals 0, and then substitute 0 into the main equation to get y equals 0. Next, we're going to go back to this equation. We've divided the x out, and we're going to divide by 4 to get this difference of 2 squares, as you should be able to tell. And we have got the two different x values, and we've just, as you see, we've just substituted the x coordinate into the main equation to get the y coordinate. Now we're half done. We need to double derivative now to be able to get this. And now we're going to substitute the points in. So for the 3 and the negative 3, it is 72. It doesn't matter which one it is because negative squared is just positive. And we know that the answer is positive, which means they're both minimum points because d2y over dx squared is positive. Next, for the x equals 0 point, we're going to substitute that in, and we see that it's negative, which means that that is a maximum. Alright, next we're going to get onto this question for the grade 9 question. I'm sure if you've watched the first episode on this channel, you should know what this question is at this point. And we're just going to go back over. I had a few choices for this question. I was going to do the trick question from last video, but I decided on this one. So firstly, we're going to substitute -2 and 11 into the main equation. This is just simple graph stuff. We know that they lie on the same point, or we know that this point lies on the graph, so we should be able to substitute the point in, and they should equal each other. So we're going to simplify this down and get -8a plus 4b equals 4. Next, we're going to simplify this and then find the derivative of this, because the stationary point will lie on the derivative as well. So we can substitute -2 in and set it to 0 because it's a stationary point, and that's what we need to do. Because we know that when the gradient's 0, x equals -2, so we can substitute -2 into x and get this equation. Next, we're going to rewrite the equation from earlier, and we're going to solve a simultaneous equation for a and b. So now we're going to multiply the second one by 6 and just add them together. We got 2b equals 6 and b equals 3. Then we substitute b into the first one, the second one, sorry, and we're going to find a. Alright, thanks for watching, guys. We're going to be doing a paper definitely next time, in the next 3 days. And if you want a specific paper to be done, make sure to use the form in the description. And goodbye.